Hello, it is my pleasure to present our work on TFRanking, Scalable Deep Learning to Rank library based on TensorFlow. Let's start with defining the learning to rank problem formally. In this slide, green shade indicates the relevance level of the item, red represents an irrelevant item. Learning to rank can be defined as learning a scoring function f that takes a list of items and produces an optimal ordering of the list items in the descending order of relevance. There are a lot of practical applications of learning to rank. In search, the most well-known application of learning to rank, we rank documents in response to user query. In recommendation, we rank items of interest for a given user. In dialog systems, we rank system responses based on user requests. And in question answering systems, we rank answers in response to questions. To support large-scale applications of learning to rank with millions or billions of training examples, we released TensorFlow Ranking Library, which was first announced on Google AI blog post on December 5, 2018. The library, which is in active development by our team, is fully compatible with other offerings in the TensorFlow ecosystem, such as TensorBoard or TensorFlow Serving. It also has flexible APIs and supports multiple popular learn-to-rank algorithms, such as RankNet, ListMLE, and others. Functions used to measure the ranking loss are an important part of learning to rank, and we generally classify them into three families: pointwise, pairwise, and listwise. In TensorFlow Ranking, we support representative losses from each of these families. In pointwise losses, we try to separately estimate the probability of relevance of each item and rank the items according to this probability. To introduce some order constraints, we use pairwise losses. In pairwise losses, we use pair comparisons to order the list. However, human judgments on pairs may lose transitivity and do not generalize to the whole list. To fully optimize the list ordering, listwise losses were introduced. In listwise losses, we aim to learn pi star, the optimal ordering of the entire list. Related to ranking losses are ranking metrics. These metrics, such as NDCG or precision at k, are used to evaluate the quality of the ranked list. We support multiple ranking metrics in TensorFlow Ranking and provide a flexible API to construct your own. Developing TFRanking is easy. There are just 4 simple steps to develop a state-of-the-art, ready-to-deploy learning-to-rank model. Define a scoring function, define metrics, define your loss, and then build the ranking estimator. Using these 4 steps, you can build a state-of-the-art learning-to-rank model in less than 50 lines of code. Here, we define a scoring function with 3 hidden layers. Here, we specify the evaluation metric, in this case NDCG at top positions. Here, we define the loss and construct the ranking estimator. Note that we can easily switch between losses by changing the loss-fn argument. Here, for example, we use listwise softmax loss. At the last line, we're done. The model is ready to train using some input data. It is very easy to get started with TensorFlow Ranking. First, read a paper, which is now on archive. Then install from GitHub using pip install and run through a simple collab. On the behalf of the TensorFlow Ranking team, thank you for listening to this video, and we hope that you find TensorFlow Ranking useful in your next learning to rank application.